Howdy. Without further ado, we continue with the paper we ended the last video. And we start from here. The Outokumpu ore has many features in common with the copper, zinc, gold occurrences of the Cyprus type. Yeah, there is gold in the region here as well, which is associated with ophiolites and with the Beshi type, which is associated with submarine mafic vulcanites and sediments. And sorry for going back up here, but the very low lead concentration is characteristic of all occurrences of the ophiolite Cyprus type setting. The specific characteristics of the Outokumpu type ore are high proportions of ultramaphites in the association, low proportion of demonstrably lava rocks in the association, hydrothermal alternations and chemical sediments. So I think they are referring here to this layering, which I think could probably have been going down through electromagnetic forces. Marked concentration of chromium in the chemical sediments, low tenor of lead, separation of the copper, cobalt, zinc, and nickel mineralization from each other. Metamorphism, metamorphic mineral assemblages of middle amphibolite facies. Polyphase deformation resulting in piling and mobilization of the ore. Mobilization. I don't know if he explains in this paper what he means by that, but it sounds very interesting, taking electricity into account. Even if the Outokumpu ore cannot be considered a unique type, it nevertheless has so many special features that there is a good reason for classifying it as a subtype of the sulfide ores associated with the seafloor mafic and ultramafic volcanism. Look at that. Where you have these striped lines here, we have nickel or cobalt. Serpentinite, talc rock, dolomite rock. Which is up here. No, it didn't draw. But the anomalous zone. Copper ore is the black one. And if you think about these things, nowadays, like there might be many others of those. Even much bigger one, but they didn't find them because they're probably so deep. Just an example. Or they didn't figure out to search for them there yet. Since they told us earlier, many of these are buried beneath some other sediments. What if these are fulgurites created by a lightning strike from huge proportions? Maybe so big that no one ever alive have seen such a thing. Only the ancients are telling us stories about these kinds of things. Here they are trying to explain a model of paleo environment during the deposition of Outokumpu type ores on the sea floor. Do you see any lightning strike or lightning bolt or a sign of electricity here? No, there is no such a thing here. So, they are explaining this like hydrothermal fluids, heat flow, and very long time spans. There are other theories, not only about these kinds of ores, because we are looking now at rather special copper ores, obviously, and other type of sediments in a very interesting assembly. You know, you could imagine that there has been once an electrical flow going through those veins at the moment of creation. As the apparition is told about the serpent dragon who jumps from the ground and goes to the heaven and goes down to the ground, and behind it leaves holes they usually fill with water. Ah, how interesting. But you can also find the diamonds there, the kimberlite pipes. And here is something which is in a way something like a kimberlite pipe, resembling, I don't know, it could be that kimberlite pipes, after they have this kind of shape, they just continue underground for whatever distance. I don't know how well they are figured out, but let me show you something about kimberlite pipes and this drawing, because I have shown this Andrew Hall video. I think so. I don't know. Or it has been in the other video which I deleted. Still, I'm in this dilemma. I don't really remember what was in that other video, because yeah, it was some 35 minutes long. So there has been a bunch of stuff in that other video no one ever has seen. But anyway, this is their explanation. And plus this explanation, we need to have to take account, like I said, millions of years. Many. So, kimberlite pipes. For this we go to thunderbolts. Mined out kimberlite pipe, Kimberley Big Hole, Kimberley, South Africa. Note the crater wall, which is natural and formed by a vortex mechanism of unknown origin. Yeah, like here, could be Venus. The electrical origin of kimberlite pipes, January 25th, 2010. One of the more perplexing mysteries in geology is the mechanism behind kimberlite eruption at Earth's surface, because these eruptions have never been witnessed. Historically, kimberlite eruptions tend to occur on the tectonically stable parts of the Earth's landmasses. Like I have shown, Finland, there is no fault line or whatsoever in the vicinity. Well away from the tectonically active zone where many active volcanoes are found, and from the stability of diamond graphite pair, we know they erupt catastrophically over a very short time, taking a matter of a half a day from the initial melting in the mantle to eruption and solidification at the surface. Another peculiarity these ancient volcanoes have lies in the close chronological association with global mass extinction events, where the globally largest eruptions of these rocks occurred at the Cretaceous extinction event. The actual process which formed the kimberlite crater or diatreme remains unknown, because there is clear evidence that these diatremes were machined downwards from the surface by a magmatic vortex effect. A huge lightning bolt. The final puzzle lies in the origin of these rather unique rocks, some 220 kilometers under the surface, well away from active tectonic zones. What could have affected the upper mantle at those depths to allow partial melting in the rapid ascent of the occasionally diamond-bearing kimberlite magma to the Earth's surface? The New Concepts in Global Tectonics newsletter issue number 43 of June 27 published an important paper by the Russian scientist Konstantin K. Kazanovich-Wolf, who proposed that kimberlite pipes are related rocks, and related rocks are linked to disruptions in the Earth's electric field caused by the electromagnetic effect of a passing cosmic body or meteorite. Earlier research by Russian scientists also point to earthquakes being caused by subterranean electric discharges, which also trigger kimberlite eruptions. In this model, it is the actual physical disruption of the Earth's electrical field by the electrically active interlooper that initiated the kimberlite eruptions, and presumably also the associated mass species extinctions. This strongly suggests kimberlite eruptions are essentially electrical discharge sites of short duration between the Earth and another cosmic body. Where electrical charge differences between the Earth and the interloper caused electrical short circuits between them. The rotary or tunneling mechanism recognized from the shape and structure of the kimberlite diatremes can then be explained as the result of a powerful Birkeland current corkscrewing into the Earth's surface, forming the smooth and steep sides of the kimberlite diatreme. Geological mysteries disappear when the plasma model is used to explain observed facts. Contributed by Louis Hissink. Louis Hissink, MSc, is a consulting geologist in Perth, Western Australia. He's a member of the Australian Institute of Geoscientists and editor of the AIG News. Greetings to Australia. And since I have a thing like this, volcanic plasma phenomena, Popocatépetl, Mexico. Whatever is going on here, but this could be a Birkeland current. Because it makes a connection. So maybe these things are really real. If they are observable in this kind. That's a screenshot from a video. And there's just like a few frames of this eruption. I don't know where the full eruption, if there would be a full video of the full eruption, we probably could see much more of that. But who knows? Should I write them and ask? I don't know. I ask someone else to, but let's see. Maybe someone else is asking for me. Maybe better, some adult. But back to this drawing. Compared to the Birkeland current version where you take plasma into the account, this is a rather boring picture. Basically, nothing is really going on. And it's the complete opposite of what, for example, Louis Hissink just told us. What do Russians think, for example, about these things? Yeah, so we read actually the whole paper. So let me show you quickly a fulgurite. And once again, I use Wikipedia because it is also about making a statement. Wikipedia is free for everyone. It's not that I'm trying to search all the time like for really obscure papers or something whatsoever. No. Wikipedia. Fulgurites, commonly called fossilized lightning, are natural tubes, clumps, or masses of sintered, vitrified, and or fused soil, sand, rock, or organic debris, and other sediments that sometimes form when lightning discharges into the ground. When composed of silica, fulgurites are classified as a variety of the mineraloid lechtalurite. So now here we have a perfect example of how they try to obscure knowledge from people by using very complicated words. But anyway, when ordinary negative polarity cloud ground lightning discharges into a grounding substrate greater than 1 million volts of potential difference may be bridged. Such current may propagate into silica-rich quartzose sand, mixed soil, clay. Yeah, I made videos about petrified clay in the yard. Or other sediments rapidly vaporizing and melting resistant materials within such a common dissipation regime. The results in the formation of generally hollow and or vesicular branching assemblages of glassy tubes, crusts, and clumped masses. Fulgurites have no fixed composition because their chemical composition is determined by the physical and chemical properties of whatever material is being struck by lightning. Fulgurites are structurally similar to Lichtenberg figures, I mentioned them earlier in some video, which are the branching patterns produced on surfaces of insulators during a dielectric breakdown by high voltage discharges such as lightning. And the Birkeland current is just a huge lightning bolt. So now, Let's go probably maybe to the last paper I wanted to show you, which I tried to show you already in the first video, but now we get to it. Now we have the fulgurites, which is this one. Helsinki, University of Helsinki, Master's Thesis, Petrology and Economic Geology. Geological 3D modeling of Ajala Metsämontu, copper, zinc, gold, argon, no, and lead. What is He? I don't know, but we won't stretch this video now any further. But they are talking about, once again, pyrrhotite and calciopyrite and these kind of things. And I just try to remember or think about the fulgurites I just showed. Because we are going to see a 3D model of the ore occurrences. And I found this paper because some of those stones which have been under investigation by the Finnish Geological Institute, I have shown in an early video, it's volcanogenic. So I remembered that, and then I thought that, yeah, maybe I look it up. What means volcanogenic? And here we have it. Volcanogenic massive sulfide deposits and associated mineralizations. So, let's scroll just down and pick everywhere, every now and then, something out. So here we are. I think I showed them already in this earlier video I made. These are very interesting waves. And this is not Outokumpu, that's another place. This has to be mentioned. But we are talking about volcanogenic materials here. And there is sulfide deposits. And sulfide is very closely related to sulfur. I didn't have time yet really to wrap my head around what's the difference between sulfur and sulfides, because sulfides are many different kinds of. Regional metamorphism in the Ajala-Orijärvi area developed mainly during D1, before microcline granites emplaced at the time when the accretion of island arcs and microcontinents to the Karelian microcontinent took place. 1.9 billion years ago? I don't know. Yeah, assemblage. Experimental results have shown that in the melt-absent reaction, muscovite begins to break down and react with quartz at around 600 degrees Celsius, producing K-feldspar and sillimanite. Yeah, he's talking about the transmutation of the elements, probably without knowing about transmutation of the elements. At over 300 megapascal pressure, 1000 whatever, muscovite decomposes and produces sillimanite, K-feldspar, and leucogranite melts. You know. Some of the cordierite, sitierite mica gneisses in the Orijärvi area contain andalusite together with sillimanite. Remember when I mentioned about the complicated words? Trying to read them is in the same, also making a point about this. Yeah, I didn't have really time to dive into these too deep because I could compare some of these with the results I got from the Finnish Geological Survey. They didn't give me any more results too much from the second part of stones I sent them. They told me that yes, we have the results, but we won't give you them. Software and creating geological 3D model. Now we get to the point. Just scroll a little bit down. I could have made this much easier, I think. But this is how it is. Look at them. Fulgurites. And since they all somehow stop here, I think they could continue below that still. But there's another picture. That's also very nice. And I think these kind of things, which are still, of course, in the ground, and probably there are many, many of these still undiscovered, especially in the area where I am, and these things are, because these are a little bit more far away, but still in the same country. And still belonging to the same surface conductivity anomaly, which is probably a very important thing to understand. How could metal just accrete at some places without magnetics? Where you have very strong magnetics, you have a current to flow. I'm still searching for this one picture. I think it comes still, but these are very amazing pictures. Copper, lead, zinc, He. I promise I will look it up. Somehow it can't be. Argon. Argon is a gas. And that's a very cool paper, because you don't even have to download, I think, in order to watch it. But look at that. The red thing is the ore. And they don't have to be, I don't know if these are copper ores or what exactly they are. But these are giant fulgurites within the ground, and here we can see on the left side depth, that surface, 150 meters down until to some 400 or even more. 480, I think I read somewhere earlier. And maybe they just still continue. And if they are connected underneath to a bigger body of the same stuff, it will create some kind of a electromagnetic field. And now as Earth's magnetosphere gets weaker, these kind of imprints in Earth's crust, they gain more and more power on our weather, because it's a positive charged area. You get high pressure system more easily built up. If it's negatively charged, low pressure system. That's why I think they are so important. And there is very bad weather in the Mediterranean. It might get even worse. And there's flooding in northern Finland. Despite it's not raining, it's just melt water, but all of a sudden there's so much. The worst floods in 50 years or something. And that's one of those points that why I find these things interesting. Because copper has its electromagnetic properties, and all other things do have their electromagnetic properties. And if these things don't look like antennas, then I really don't know. These are antennas. Charge accumulates on peaks, and if there are like many of these different kinds, they create by their own electromagnetic field on the surface. And it will create magnetic vortices. That's why it reacts with the weather. But anyway, and there are also very good proof of these things being created by electricity. Giant lightning strikes, basically. Electromagnetic plasma discharge events. And not by billions and billions of years on the seafloor somewhere. Yes. Thank you.